Hello, I welcome you all. The problem reads the tractor is used to lift a 150 kg load B with a 24-meter long rope, boom, and a pulley system. If the tractor travels to the right at a constant speed of 4 meters per second, determine the tension in the rope when SA is equal to 5 meters. When SA is equal to 0 and SB is equal to 0. These problems, or both problems, are coming from the Engineering, Mechanics and Dynamics of 14th edition by R.C. Hibbeler. We're going to only solve one in this video. We'll solve the next one in the next video. So let's call this as case 1, 1331. Alright, so what is happening here? We have the rope. We have the tractor here tied to the rope, and this rope has a length of 24 meters, and the tractor is moving to the right at a constant speed of 4 meters per second. Okay. At this particular rope, okay, as SA changes, its direction as well changes. Okay, so need to compute, work out SA as well as work out the length, this inclined length using Pythagoras theorem, and later on relate the positions B and A. Let's do so. So we have SA there, so just say SA, SA squared, right? Let's do so. So say SA squared, plus 12 squared, then this to the power half, then this one here to be plus 12 minus SB, and this is equal to 24. So writing this, it just becomes plus 144 to the power half, right? 12 minus 24, the length, right? Then this 12, we take it the other side there, this just becomes equal to 12 like so. Let's take the derivative using power rule for the first one. This just becomes SA squared like so, 144 to the power half like so, and then the inside we have 2SA by SA dot, and then minus SB dot, then equal to 0. Alright, so we are interested in SB, there the position, the tension there, we want the acceleration, so let's make SB subject to the formula. So we'll have SB like so, SB dot, but before we do so, let me just cancel out some parts. So this 2 and this 2 goes, and I will have only SA squared plus 144 to the power half SA squared like so. So let me factor out the inside so that I just make this work easier. Okay, if I factored out the inside, this just becomes SA squared 1 plus 144 divided by SA squared like so. Then I close, then to the power half SA squared. I can factor out the SA there, mind you. All this, it will come down, right? When I factored it out, it's coming down. So this just becomes like so, 1 over SA because of this negative power. Okay, then this just becomes plus 144 SA squared to the power half SA dot. So this and this goes, and then what I remain with is just SB like so, equal to 1 plus 144 divided by SA squared to the power half, then SA dot. Okay, so then let's take the second derivative. This double dot. Okay, then we'll use the product rule. This one double dot, product rule, let's start with just 1. This becomes minus half, 1 plus 144 divided by SA squared. Then this one becomes to the power 3 over 2. Then the inside this is a 0. This one here becomes a 0, so we just have a minus 144, right? And by this, which is just going to be equal to 2 by SA and SA dot, and everything divided by SA to the power 4, right? Okay, and then this one maintains the way it is, and then we say plus, then this one just maintains 1 plus 144 divided by SA squared to the power half. Okay, then this part just becomes SA double dot. Okay, which is the acceleration, right? Great. Okay, so once we do this, so we know that the tractor is moving horizontally with constant speed. So the horizontal component, we expect the horizontal component to be equal to 0, right? So SA double dot, which is the horizontal component, we expect this to be equal to 0 because the tractor, because we have SA, we have SA dot equal to 4 meters per second and is constant. Alright, so because this is 0, then this whole component here is 0. Great. So remain with this. We are not yet done. We have been given some of the things that we need to consider here. We will need to find the value of where is the equation? Here is the equation. We need SB. Okay, we are going to need SB when SA is equal to 5. So let's find SB. So I'll say let's find SB at SA equal to 5. So using this equation, okay, our SB therefore is just going to be equal to, let's calculate it. What is our SA? 5. So we are saying 5 squared plus 12 squared, okay, square root of that, okay, then plus 13, okay, and then minus 24. Okay, so this is just going to be equal to 1. Okay, so 5 squared plus 12 squared, square root of that, plus 12 minus 24, SB, that's SB. Alright, so we have SB. So once we have SB, then let's find SB double dot. Okay, so let's find SB double dot, okay, using this equation, okay, so we have everything. Our SB double dot, which is just equal to AB, is just equal to, let's work it out, it is here. We know that our SA is a little bit long, of course. This part here we can cancel out. When with 3 we cancel this. So let's work it out. You see how it goes, and then this one just becomes squared. Alright, we are multiplying it by that. Great, so let me start with the rest. So I have 144 divided by 5 squared. Okay, plus 1 to the power minus 1.5. Okay, times 0.5 times -1, then times -1 again, then times 144 times 2 times 4 squared. Okay, and then divided by 5 cubed. Okay, so we have a 1 point. I'll need to repeat this to check it if I'm correct. 1.0487. Okay, 0487. So let me repeat it. 144 divided by 5 squared, or divided by 5 squared, plus 1 to the power minus 1.5 times 0.5 times 144 by 2. Okay, by 4 squared, right, divided by 5 cubed. Okay, where did I go wrong? Again, I repeat. 144 divided by 5 squared plus 1 to the power minus 1.5. There and there it cancels out. Then times 144 times 4 squared divided by 5 cubed. 1.0487. Right, so this is our AB. So let's tension this cable like so. We section it, so we expect to have some tension force the same like so, and also the other side like so, and then this part here will have a tension force like so, and then this part here will have a tension force like so. Okay, so there we go. So tensioned it, and that's the tension force. There we go, like that, and there we go, like that. Okay, so let's call this our tension force T. This is T. This is T, like so. Right, and then we do have some weight. Okay, like so. So let's call this as WB, and this is just equal to MB times G, and therefore our WB is just going to be equal to 150 by 9.81, and this is equal to 150 by 9.81. We have 1471.5 Newton. So applying the equations, the equation of motion in the vertical direction, so yes, summation of forces in the y equal to MAY, where our M is just equal to 150. Then what do we have? So again, let's say this acceleration is moving up. Okay, This is our kinetic diagram. This is our MA. So then we are going to have T minus WB equal to MA, and then we have T minus WB is just 1471.5, right? 150 by 9.81, 1471.5, and this is just equal to 150 by A, right? AB, and we know to say our AB is just equal to 1.0487. So T therefore minus 171.5 is just equal to 150 times 1.0487, and therefore our T, computing our T, will get the following. So 150 times 1.0487, okay, plus 147.1.5. So T is 1628.81 newtons. So 1471.1 plus 150 by 1.0487, 1628.81. So this is the tension in the rope when SA is equal to 5. Alright, so I think this is about it. And I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.